Hi everyone. So this is Rizwan and I am going to upload my first video lecture on chemical kinetics, and you will get detailed notes of all chapters individually on YouTube time to time wise. So hope you like this video. So without doing late, moving on to this topic, a very interesting topic, chemical kinetics. So before going to the topic, let us know what is chemical kinetics. So know that it is nothing but a branch of science, but a branch of chemistry, which deals with the rate of a chemical reaction. Which deals with the rate of a chemical reaction and the various steps followed by it, So the branch of chemistry which deals with the rate of a chemical reaction and the various steps involved in it is known as your chemical kinetics. Clear? Got my point? Very good. So now moving on to the topic, next part, how many types of reactions are there on the basis of rate? So know the concept rate. What is rate of a reaction? Rate of a reaction is nothing but the velocity or speed, the speed at which a reaction proceeds, the time at which the amount of reactants consumed and the amount of product formed are called the rate of a chemical reactions. So on the basis of rate, the reactions are of three types. What are those? Instantaneous reaction, this is your first reaction, instantaneous reaction, moderate reaction and slow reaction. Instantaneous reaction means the reactions that occurs at instant of time, means very fast reactions. So now let us discuss one by one. So what is instantaneous reaction? I have written the definition in short form, that takes place at once. That means the type of reaction that takes place at once, at that instant of time. As soon as the reaction starts, the product starts forming or beginning. That type of reactions are called instantaneous reactions. So in order to memorize the examples, I have written the short forms like PAD. That means precipitation reaction, acid base reaction and decolorization of potassium permanganate with ferrous sulfate solution. So memorize or remember these examples and the type of reactions as well. So examples of precipitation reactions is your, when silver nitrate reacts with sodium chloride in aqueous medium, then it will form silver chloride as the precipitation or precipitate. The precipitate is shown by downward arrow pointing downward, and it is of white color. Its color is white color precipitate along with sodium nitrate is formed. And the second type of example, your acid base reaction. As you know, any type of acid when reacts with a base forms salts and water. I have taken the simplest example as your, when sodium hydroxide reacts with hydrochloric acid, it forms sodium chloride and water. This is an example of acid base reaction. And the another example is your decolorization of acidified potassium permanganate with ferrous sulfate solution. That means when potassium permanganate KMnO4 reacts with sulfuric acid H2SO4 and FeSO4 ferrous sulfate, the ferrous sulfate is oxidized to ferric sulfate. The ferrous sulfate is oxidized to ferric sulfate, Fe2SO3. So MnO4 reacts with H2SO4 and FeSO4 forms K2SO4 potassium sulfate, manganese sulfate MnSO4, ferric sulfate Fe2SO4 whole 3 along with water is formed. So this is an example of instantaneous reactions. So moving on to the next topic, moderate reaction. So what is moderate reaction? So moderate reactions are those that takes at measurable rate, and I have written the definition in short form. You could write the definition as I am saying to you. Simply note down the definition as the moderate reactions are those that takes place at measurable rate. Measurable rate means that takes some times for completion, not a long time, not very short time, but intermediate time. So examples of moderate reactions are BAD, that means base hydrolysis of ester or basic hydrolysis of ester, acid hydrolysis of sucrose, D decomposition of hydrogen peroxide. So in that case we have written it as PAD, and in order to memorize the reactions of examples of moderate reaction, simply remember BAD, bad. PAD, bad, basic hydrolysis of ester. When ester, I have taken ethyl acetate as an example. Ethyl acetate, when reacts with base sodium hydroxide, it will form sodium acetate and ethyl alcohol. This is an example of moderate reaction. Decomposition, acidic hydrolysis of sucrose is nothing but the sugar that we are consuming in our diet. So it has the molecular formula C12H22O11. When reacts with water, that means when it is hydrolyzed in presence of acid H plus, you could write it as H2SO4. So it will form glucose and fructose having same molecular formula C6H12O6 and C6H12O6, but these two compounds are different. You will study in detail about these two molecules in your biomolecule chapter. And the third example is your decomposition, D, decomposition of hydrogen peroxide. When hydrogen peroxide is decomposed, it forms water and oxygen as the product. These are examples of moderate reactions. And moving on to the next example, next type of reaction is our slow reactions. Slow reactions are those that takes long time for their completion. That the long time may be several hours, 1-2 days, or several days, even sometimes 15 to 20 days also. So that is a long time, so that's why these are called slow reactions. So examples are roasting of iron. When iron is exposed to atmosphere, it comes in contact with moisture of the atmosphere, oxygen and carbon dioxide, and therefore it forms rust having formula iron. When reacts with water and carbon dioxide of the atmosphere, they form FeOH HCO3. This is the formula of rust. It is an example of slow reaction. Got my point? Very good. And another example is your fixation of nitrogen or nitrogen fixation, that is done by azobacter, that is present on the roots of seeds. That are the structure are like bubbles, small bubbles. So I have not written the equations here. You can write from your textbook. So moving on to the next. Why the rate of a reaction differ? The question comes, why such type of reactions are observed? Why some reactions are fast reaction whereas others are moderate and slow? Because of the bond dissociation energy difference. We have known that when a reaction occurs, the reactant molecule starts breaking, and at the same time new bonds, that means the product molecules starts forming. When the reactant molecules break, energy is required to break the bond, and when product molecules are formed, energy is released by the formation of product molecules. Because of the energy difference between the reactant molecules as well as the product molecules, the rate of a reaction varies. The energy difference differs for different types of reactions, and hence the rate of reaction varies. I have written the same note here. In a chemical reaction, the reactant molecules break, that means energy is required for their breaking, and new bonds are formed. That means in the new bonds are formed in the product, and energy is released during the process. Because of the energy difference between the reactants and products, the rate of a chemical reaction varies. Now the question arises, what is rate of a reaction? Your actual topic or your actual course starts from this, or starts from here, and know that the rate of a reaction means the amount of reactant consumed or the amount of product formed. Amount of reactant consumed or amount of product formed in a unit time, in a given time, in a chemical reaction is called your rate of a chemical reaction. The quantity of reactant species consumed or the quantity of product species formed in a unit time is called your chemical reaction. A gives rise to B. So rate of reaction A is consuming, that means reaction is consumed in a chemical reaction, therefore its concentration will decrease, therefore it is written as amount of A consumed by time taken minus, I have written here, the minus sign is written here, minus del A concentration by del T. This is the change in concentration of reactant. and rate of reaction of B, that means product, the concentration of product is increasing, therefore it is the rate of product means rate of the B is written as amount of B formed by time taking. That means I have written it as plus sign, plus del B, del concentration of B increases with respect to time, where del A is equal to A concentration final concentration of A minus initial concentration of A, change in concentration of A, and del T is the change in temperature. Clear? And now for a general equation of the type, A times plus B times gives rise to C times and D times, the rate of reaction is written as minus 1 by A by del T. The coefficients will be the reciprocal, and since A is consumed, hence minus sign is given before it. So minus 1 by A by del T is equal to minus 1 by B by del T plus 1 by C by del T and plus 1 by D del T by del T. And the unit of rate of reaction is, since rate is expressed in terms of change in concentration per unit time, hence the unit of concentration is mole per liter, and the unit of time is second. Therefore the unit of rate constant is unit of rate is mole liter inverse second inverse, or in terms of atmospheric pressure, if the reactants and products are gaseous species, then its unit will be atm into second inverse. So now another concept is your average rate. So what is average rate? It is defined as the rate of change of concentration per unit time. Know that average rate of reaction does not give the exact rate of a chemical equation, because it is determined within a range, average within a range. Since within a range the rate of a reaction may vary, hence average rate of reaction does not give the exact rate of a reaction. Hence in order to find the exact rate of reaction, we have to consider another concept that we will discuss after this concept, that is your instantaneous reaction. So I am running through sweat. So consider the example, A gives rise to B. A reaction proceeds as A gives rise to B. So the average rate of reaction is written as change in concentration at a given time divided by time taken. So minus del X by del T. Yes, look here. And I have written here as del X, not del A or del B, because the change in concentration occurs over a range of temperatures. Therefore, in general, it is written as minus del X by del T, and del X, change in concentration of X, may be written as X2 minus X1 and T2 minus T1, where X2 and X1 are the concentration of reactants, and T2 and T1 are the change in time respectively. The average rate of reaction does not give the true rate of a chemical reaction, as I have already told you, because the rate of a reaction is not constant but changes with time. Got my point? Very good. Now it is better to express the rate of a reaction at a particular moment and not as average rate of reaction. The concept that just before I have told you, instantaneous reaction. So know that instantaneous reaction gives the exact rate of a reaction. Sorry, instantaneous rate gives the exact rate of a given chemical reaction. So what is instantaneous rate of reaction? The rate of reaction that is obtained at a particular instant of time, exact moment at a time. So it is defined as the rate of change of concentration of any of the reactant or product species at that particular instant of time. Rate of change of any one of the reactant or a product species at that particular instant of time is called instantaneous rate. So A gives rise to B. The rate expression for instantaneous reaction is written as instantaneous rate reaction is given as minus dA by dt, derivative of A, change in concentration of A with respect to T. Why? Because concentration of A is decreasing, and plus dB by dt, where dA and dB are extremely small change in concentration of any species during extremely small interval of time. extremely small interval of time. So note that the average rate of reaction approaches to instantaneous rate of reaction when del T becomes smaller and smaller. When the time changes, average rate of reaction is determined over an appreciable range. So when the time approaches 0, that means when time decreases, the average rate of reaction will approach to instantaneous rate of a reaction. And the expression for average rate of reaction is minus del A by del T. When the time approaches 0, del T approaches 0, it will convert into what? Instantaneous rate, that means dA by dt. In the same way, plus dB by dt concentration when time approaches 0, average rate of B is equal to instantaneous rate of B dB by dt. So for example, two molecules of dinitrogen pentoxide when decomposed forms nitrogen dioxide and oxygen, and instantaneous return is written as minus 1 by 2. Minus 1 by 2, why? Because the concentration of reactant is again decreasing. D concentration of N2O5 by dt, because we are writing it for instantaneous reaction, is equal to plus 1 by 4 dNO2 concentration by dt is equal to plus dO2 by dt. So this is an example for instantaneous reaction. So this is all for today. Hope you enjoy this video lecture. Thank you. God bless you all. Thank you.